Okay, perfect. Good afternoon. Again, thanks for joining me. Today, I'll be talking about ADOT, which is Amazon's distro for OpenTelemetry. You have had some masterclasses in the previous session about OpenTelemetry, what it is. I also had few slides. Good thing it's already covered from better person. So I'll be able to fast forward that and show you the important stuff, which is about ADOT and how it works with serverless. To start with, how many of you use AWS ecosystem today? Many of you. How many of you work with Lambdas day in, day out? Perfect. Okay, so it will be relevant to you, hopefully. For my introduction, I am Zameer Fouzan. I am the lead developer advocate for Neuralink. I am also one of the AWS community builder. I am an active OpenTelemetry advocate at Neuralink. I talk Neuralink. I work with Neuralink, but I talk about OpenTelemetry, how OpenTelemetry is better for ecosystem, what it is, what the future of OpenTelemetry is, and why it is good. So today's topic is about ADOT. I'll briefly touch upon OpenTelemetry, but fast forward, since most people have already covered that, you are already familiar with that. We'll focus into what ADOT is, why AWS is also investing into that. I'll briefly touch upon what you require on instrumentation side. We have seen one diagram in the previous session by Srini, where he has covered on the infra side. I'll showcase you a brief on how you can cover from the application side, then quickly move on to the Lambda part. We'll see what the ADOT layer is and how you can start using that pretty easily, and how you can start capturing all the rich telemetry that you have seen in one of the demos in the DXO2 platform, which was from OpenTelemetry ecosystem itself. Lastly, I'll share you some tips and some pitfalls to avoid when you start working with OpenTelemetry as well as ADOT. Okay, since you work with Lambda and serverless ecosystem, is this you when something goes wrong? What happened behind my code? Is it the code? Is it my configuration? Is it the invoking HTTP endpoint? How do you actually debug that? You have multiple sources, you have X-ray, then you have logs, then you have debugging logs, you have to enable the debug. Is it your extension layer? Too many things, and it's too scattered. And there's no fixed standard even within AWS ecosystem if you have to figure out the problem. You have SAM CLI, you have CDK, you have serverless framework, and many other things. So how do you standardize that? That's where OpenTelemetry is shining on standardizing the telemetry collection. So on the instrumentation phase, OpenTelemetry is already very good. First, you have heard of OpenTelemetry in the previous session. Yes, so expecting all the hands to be up. Keep your hands up if you have used OpenTelemetry or are actively exploring OpenTelemetry. Awesome. Just a brief background of how it came into existence. There were two famous projects, OpenTracing and OpenCensus, before 2019. One was built at Twitter, another was Google's child. Both of these projects were clubbed together and formed as OpenTelemetry and donated to Linux Foundation, which is now known as OpenTelemetry. I'll not get into the details of that. It's vendor agnostic. We have heard that. It standardizes how you can collect the telemetry, how easy it is making to instrument your application, infrastructure, including the eBPF section now. So all of this is pretty standard now. And another one of the USP is how it's making it easy to export it to any choice of your observability backend. It could be Grafana, it could be your Jaeger, it could be Zipkin, it could be DXO2 platform that you have seen in the previous, or it could be Neuralink. So you can easily choose without having to re-architect your application once you have instrumented with OpenTelemetry. On topic of how quickly it is rising, since Srini has already touched upon, this is how quickly it is visually. The blue one that you see is Kubernetes, which has been in the ecosystem, Linux ecosystem for a long time now. It's right behind that. And it's not just in terms of contribution, but also in terms of adoption. You have seen Broadcom is also adopting, AWS is adopting, Microsoft is also working on integrating OpenTelemetry natively in their ecosystem on Azure. So that's how quickly it's rising, and that's how quickly it is adopting. That's why OpenTelemetry is the next big thing. Building blocks to be familiar with. When you start with OpenTelemetry, there are key things. OpenTelemetry is not one single framework, it's a specification. So the specification defines how the APIs should be, and APIs are utilized in building the SDKs. So there are language SDKs like Java, Python, .NET, whatever language you want to use, there are SDKs available, and they are built on top of these specifications. So if you instrument using Java today and within your own organization there is another team who are going to use .NET, they don't have to relearn things. You can follow the same documentation and specification that this is what you want to do. If you want to implement some custom span, your specification and learning is going to be the same. The APIs are going to be the same. So it's easy to adopt as well across ecosystem. Collector, I'll not get into it. Srini has explained it very nicely. He touched upon the receiver processor, how processor is a powerful piece, and how you can decorate your metadata or drop some telemetry. Lots of things you can do in processor. Srini has touched upon that, so I'll fast forward that. And again, the exporter, the three main components of OpenTelemetry collector. Now, collector, as Srini also mentioned, is a very important and powerful piece from OpenTelemetry, because that's the central piece from where you can get the telemetry and also post the telemetry to your choice of backend. So that becomes a very central piece within OpenTelemetry ecosystem. Why am I talking about this? Because to talk about ADOT, you need to be familiar with how the OpenTelemetry ecosystem first. ADOT is actually built on top of OpenTelemetry collector and SDKs, which AWS takes every 90 days, repackages and optimizes for AWS ecosystem. It is backed by AWS's in-house team. So they take the upstream project, build it, optimize it, make it AWS native. So any kind of contextual information, any kind of metadata that's required, it's already done and taken care by ADOT when you start using that. Can you use OpenTelemetry collector directly in AWS ecosystem? Yes. Would you have to add additional metadata if you want to identify the service, the identifier like trace IDs? Yes. If you're using ADOT, you don't have to worry about that. All of that is taken care of. Lastly, within the AWS ecosystem itself, if you are using managed Grafana or managed Prometheus, it's easy to adopt to ADOT since it's going to work as a first-class citizen in the AWS ecosystem. How it works? Once you deploy ADOT, there are multiple deployment modes. I'll touch upon that. My focus for today will be using ADOT on Lambdas. So how it works is once you deploy ADOT, it's going to collect the traces, correlate the application metrics. Both of these are then forwarded to the collector. Collector decorates that, adds the contextual information for the trace, for the metrics within the application context. Then you can choose to export it to any choice of your backend. If you're familiar with and use AWS X-Ray, CloudWatch metrics, you can do that without any additional configuration. It's going to follow the same practices and same ecosystem. You don't have to modify. But if you want to export it to like managed partner services like Prometheus, Grafana, or any partner solutions like Broadcom or Neuralink, you can do that. All of these sources on the left hand side, you can pull these metrics, forward it to ADOT. ADOT can then process and export it to all of these other options on the right hand side. So on the right hand side, you can see it's X-Ray if you want to use OpenSearch, if you want to perform some kind of pipeline on Kafka or queuing, or if you want to just send it to a raw file for any kind of analytics, you can do that. Okay. In the deployment options on ADOT, there are multiple things that are production ready today, starting with as simple as Docker. If you want to deploy it on EC2 as a daemon or a service, you can do that. It's natively supported on ECS and EKS using add-ons and Helm charts. So you can just choose the add-on and ADOT collector will be deployed in your ECS, EKS. It's supported on App Runner as well. And using Lambda layers, ADOT can be deployed to all of your Lambdas pretty easily. I'll show you what the configuration looks like, and if you want to upgrade, how it does not affect your Lambdas as well. Let's touch upon the instrumentation. The long GIF that you're seeing that I keep scrolling, if you are going with the SDK part of instrumentation for your application, which can be automatic instrumentation or manual instrumentation. Regardless, you'll have to import a lot of packages. You'll have to add multiple things for traces, metrics, logs. You have to decorate. You have to add a wrapper. And all of these SDKs, as I mentioned, are available with Go, Java, JavaScript, Python, .NET, PHP. These are production ready on all three APIs. Elixir, Rust, Ruby, there are some APIs which are still in development mode, but most of the APIs for traces are production ready today. Now, once you have your SDKs, you can, traditionally, if you're instrumenting an application with SDKs with OTel, you'll add a package. I'll take a very simple example with Node.js. You add an NPM package, you enable the automatic instrumentation, it's going to capture all the telemetry from Node application. Same Node.js code when you deploy it to Lambda. using the node runtime. You can use the SDK method as well, which are available using a single package. Again, this package instrumentation-AWS Lambda is available across the languages. So if you are using it in single language, does not mean it won't be available. Any package that's available will be available for other languages too. So just use this package if you want to deploy a node app as a Lambda. You define the request hook and response hook, and one key thing that you have to do is disable the AWS context propagation. I'll touch upon this towards the end when I am showing you the demo, why that is important. So this is an official Lambda plugin from the OpenTelemetry ecosystem, worked by the AWS team and provided for anyone who wants to use OpenTelemetry. And that's what is required if you want to do it the SDK way. You have to first add the SDK, write a lot of instrumentation, write a lot of code, add the hooks, then you will be able to capture the telemetry from your Lambda functions. And this is what you get, standard telemetry. I'll not get into what the trace looks like. This is the trace breakdown. You'll see that there are API calls and all the attributes. But when you're using ADOT, it's fairly easy. This is a serverless framework. How many of you are familiar with serverless framework? Quite few of you. If you're not, if you're using SAM or CloudWatch, CloudFormation as well, the concepts are similar. Serverless framework just adds a wrapper to make it easy. So in this one, I'm using serverless framework to create one API, one single function, and on top of that, I want to add my Lambda layer, which is of ADOT. So we have our previous Node.js function. We'll remove all the SDK instrumentation. We'll just add our layer. Now layers are, ADOT layers are language specific. So you'll notice here it's Node.js. So you have to add a language specific layer that you want to instrument your Lambda for. Once you add that, there are a couple of things you'll require. Other thing is AWS Lambda exec wrapper, which tells Lambda this will be the entry point of the file for my Lambda execution. The default handler that you deploy, it can be index or it can be any other function. You have to override that. So SDK from ADOT can take that, wrap it around and capture all the telemetry from your Lambda function. Those are the two important things. The third being OTel Lambda disable AWS context propagation. And mind you, these are all environment variables. You don't have to modify your code at all. Again, this is debatable if you're exporting it to AWS ecosystem like CloudWatch or X-Ray, you don't have to add that. But if you're exporting it to any third-party backend like Grafana or Jaeger or any of your own managed service, you will require that. I'll show you why. Now, once you have that, you don't have to change anything, no code modification. This is what you'll get. Once you add the code, you'll get the complete traces in X-Ray. Now, this is one example where I have my Node.js service, which is talking to 3 different Lambdas, and it's making a HTTP API call. All of these traces is being captured without modifying a single line of your original Lambda source code. That's how easy it is to capture telemetry from your serverless Lambda functions by just adding the ADOT. Now, ADOT as a layer works on a separate thread, which is using decoupled processor. AWS has its own ecosystem of extension APIs and telemetry APIs. It taps into the same thing. So your runtime for your code and Lambda functions remains same. The telemetry being captured and executed is happening on a different thread. So you are not built for your function, but for ADOT there is an overhead, so you have to be mindful. You don't add a lot of processing there. If you want to do that, you can export it to a centralized collector where you can decorate this telemetry. So cost factor and execution factor, 2 things that you need to be mindful of. Now, if you're exporting it to AWS, it utilizes both X-Ray and W3C. So tracing is one of the biggest factor and biggest plus point of OpenTelemetry. If you're exporting it to AWS, AWS has its own X-Ray trace ID, which it's used to add the context. When you're exporting it to AWS, it works with both. Because OpenTelemetry uses W3C headers and AWS uses X-Ray headers, both work in tandem. There is no conflict. You get the complete picture of what is been happening, and you get, if something goes wrong, you'll also see what has gone wrong way without breaking the span or without having any gray area. Now, export to any backend, it's highly configurable. I'll show you one configuration. This is one example where I've exported to New Relic. And modification is only on the environment variable, the endpoint that I've included in the previous configuration. I have not modified the A. configuration, nothing on the code side. One simple endpoint to where you want to export, it exports it to your choice of backend. You get the complete enriched telemetry, this breakdown of your traces, span, in the exact same way that you will see in the AWS X-ray. Now, this is the hotel collectors configuration file. You can attach another configuration file if you want to modify your traces or if you want to enrich your telemetry. This file can live in your source code root folder, or it can be in S3, or it can be an external file which can be pulled and referred directly in your Lambda context. The A dot refers to this configuration once it's found, and it can apply all of these configuration on the processors if I want to batch it, and any kind of pipeline that we have to send our telemetry or process our telemetry. Again, very scalable. If you want to modify it on the go, it's pretty easy that you just modify your collector configuration. Okay, let's get into demo. I'll extend the demo, but I'll finish it before 1. It says don't panic, I'll finish it by 1, but I'll finish it before that. First thing I want to show you is the configuration. So this is my serverless framework, which is written for AWS. Okay, let me close this. This is specific to how we export it to AWS ecosystem, but I'll also touch upon the configuration that you will require to export it to any other third-party backend. Now, not getting into the serverless framework configuration, I have the runtime, I have my region, the architecture. I have one API gateway endpoint, which is talking to one of the lambdas. One thing that you will require first to start with A dot is the layer. The layer information you will find directly into the AWS hotel documentation page. You will just have to update your region as well as your account ID. Architecture as well as the region. All of these UUIDs are already provided to you in the documentation ready-made. So if you have your lambdas running in different environments or different regions, you just have to update that. And it's advised that you use the latest version because SDK wise and collector wise, all of that are optimized for anything that's latest coming into the OpenTelemetry ecosystem. Once you have added the layer, you will require one key thing, which is Lambda execution wrapper. As I mentioned, this is going to override your actual handler, which is index.handler in this example, and it's going to wrap it around, add all the instrumentation with OpenTelemetry, capture the telemetry from execution with metrics and traces included. It's not shared?
I mean, not there for recording. I'm still seeing the PPT.
Let me check. I've shared the whole screen. Let me reshare again. Good now? Okay. Where was I? Yes, we added the layer. Then we added the wrapper. Again, it's so flexible that everything can be controlled using environment variables. Here there is one configuration which you can include depending on your use case. If you want your traces to be completely sampled, everything, you can define that. Or there is something called sampling strategy. If you want only 20%, 30% traces to be sampled, you can apply that in the collector file. Here I'm going ahead directly without the collector file. I want to capture all the traces. And in this, if you want to export, all you have to add is the endpoint and if there are any authentication. It's the same thing. All that will change is on the right hand side which backend you are exporting it to. Let me zoom this a little more. So in this case, it's OTLP for NR data, which is Neuralink platform. Grafana has its own endpoint if you're using Grafana Cloud. DXO2 have their own endpoint where you can export all of this. That's all that's required to deploy a dot on your Lambda functions. And you can scale it up. So I have multiple Lambda functions. All I have done is added the layer, added the environment variable, and I'm good to go. Tomorrow, if you have to upgrade your layers, all you have to do is change the version. None of this has to be touched again. If you have to remove your A dot again, you can remove it directly by removing the layers. Your actual Lambda source code does not have to be touched. So if you are someone from ops team who wants to get insights, you can do it independently. But if you are from developer, who are actually writing code for Lambda functions, again, you don't have to worry that your code will be affected. This is done independently and they don't mess with each other's execution. Let me show you what it looks like once we have exported. So this is my one function, which is again on exporting everything to AWS. You'll see in the configuration, I have my one single layer for Node.js, ARM64, latest version. I have my runtime here, that's one configuration. Then comes the environment variable, which requires all of this, which is wrapper, the config UI, service name. If you want it to be different from your function name, you can define your OTel specific service name, and sampler. If again, depending on the use case, if you want to enable sampler. One thing that you do require if you are using it to export it to within AWS ecosystem is you have to enable active tracing. So in this, you will see Lambda services active tracing. Because ADOT works with AWS ecosystem and has its own OpenTelemetry specific W3C header, we want it to work together. We need to enable this. So traces from ADOT collector can flow into X-ray. If you don't do this, it will work, it will not fail, but you will not see the traces. It will error out in the error out silently. Now, what do we get? As I showed you in the screenshot, we get the complete traces, which says from the client invocation, which can be HTTP API. It invokes the Lambda context, has the actual Lambda function, invokes two different other Lambda functions, which in turn is calling the third-party API from third level of services. And if you can get the breakdown as well, let me remove this. You can get the breakdown as well of what all operations are happening behind the scene. You'll see it's calling the multi-hop endpoint, which is my return endpoint, which is calling all the multiple Lambdas. I see all the breakdown of TLS connect that's happening, the middleware from Node.js Express ecosystem. It's calling the micro task, which is another function call. Then it's also giving me the breakdown of all the functions and external Lambda functions that I'm calling. So subtask Lambda, catfax Lambda, I'm getting the breakdown. Something goes wrong or something is not behaving as expected, or there are slow spans and latency, you'll get everything highlighted directly in the span level. So the best part of OpenTelemetry on traces, working very well with AWS ecosystem. Now let me give you another example where I have exported to an external tool. Now you'll get the exact same output. You'll see from my Lambda function, there are three calls being made, one to catfax Lambda, another to subtask Lambda, and there are calls to third-party API. So I have my exact same thing just by changing the endpoint to where I want to export. I get the complete exact same breakdown, exact same spans, and all the scenarios where the spans are actually slow. Now depending on the platform that you want to use, you can just change the endpoint. That's all that will be required. Also on the error side, if you want to focus on the errors, how it has gone wrong, you'll see ADOT automatically decorates everything, captures all the detail. So one of my instance, the Lambda function failed, the trace gets captured. So downstream Lambda failed, I see it says internal server error. So I can see in the complete flow of multiple Lambda execution where it has gone wrong and what is the error. If you want to attach logs, you will get the logs as well, but that's how easy it is to deploy ADOT on that. I'll switch back. That was all the demo, but I'll be available to answer any other question. Again, in interest of time, I'll not take it till 1 p.m. Now, ADOT is good, OpenTelemetry is great. Let's start deploying it into our production on Friday nights. All good? But couple of things you need to be always mindful when adopting new things, regardless of the tool or open source or not. There are a couple of things that you need to be mindful. First thing is when you're instrumenting Lambda, there are two key things. This goes across OpenTelemetry ecosystem. So if you're using SDK, which is manual instrumentation, even though you are using automatic instrumentation of those SDKs, it is still considered a manual effort. You get the complete control, but it's hard to scale. So you have to choose your trade-off. What do you want to do? You want to scale first, then take the complete control, or you want to complete control from day one, you want to start instrumenting. So you have to be mindful on that, and it's difficult to scale. Imagine you have 10 different functions all written in 10 different languages, and you have to add the same instrumentation. How would you do that today with SDKs? You can, it will take a lot of time. On the other hand, we have A dot layers. It's automatic by default by nature. Once you add the layer, it supports all the major languages. It can capture all the instrumentation, all the telemetry from your functions, and you can add it to all 10 different functions which are written in 10 different languages. All you have to add is language specific layer and you're good to go. One key thing that you have to be mindful is A dot for now does not support logs from your Lambda. So if you have to capture the logs, you'll still have to rely on the CloudWatch logs for that. And if you are working with OpenTelemetry collector today, it's not exactly the full-blown version of collector that is being packaged with A dot layer. Now, A dot layer is what I'm talking about. There is another version on A dot which works with ECS, EKS. That is a complete OpenTelemetry collector. You'll get the full-fledged functionality there. This has been done for a couple of reasons, because Lambda execution, people generally choose Lambda so that it's quick, short task. So collector does not add much overhead for you. So it's stripped down version where a lot of things are removed, but if you want, you can build your own Lambda layers as well using the A dots guide. A few tips if you're using to export it to third-party tools, any third-party tool from using A dot, you need to disable the context propagation, because this will interfere with the X-ray ID with AWS as well as the OpenTelemetry. So you will not get, you'll be seeing the fragmented traces. And when you're using OpenTelemetry configuration, again, be mindful with Lambda layer of A dot, a lot of processing configurations are not available. That's again by design so that you don't overload your Lambdas. Use environment variable where possible instead of collector configuration, because it's easy. The collector configuration is an external dependency. So if there is a YAML formatting issue also, your Lambda extensions will start failing, which will result in your Lambdas actually failing. So that will be a major impact. So use environment variable where possible. OpenTelemetry has provided quite rich, flexible configuration that you can drive just by using environment variables. Use the correct layers. I've done this in the past. It's very easy to mismatch just between AMD and ARM64. You can confuse and use the wrong layer. That will also result in a lot of failures which can cascade to all of your Lambdas. Lastly, the important part that I've been talking about is Lambda layer uses decoupled processor, which is a kind of processor part of OpenTelemetry, which runs in a different stream. So it does not impact your execution of actual Lambda function. So if you want to start with, you can start worry free, but if you want more configuration, you can always build your own layer. With that, I'll conclude. You can scan, you will be able to find a couple of resources where you can find repository with OpenTelemetry applications. If you want to get started, there are a couple of blogs on how you can instrument using A dot and OpenTelemetry SDKs as well. I'll open it for Q&A if I have no time left.